This next program that you're going to do, Guessing Game, is my favorite program in Comp Sci 1. So let me describe what it's all about, and then I've got a little bit of notes on it because we need to know how to make random numbers to do this game. So this should take probably 15-ish minutes or so. All right, so the program's called Guessing Game. Task says write a program that displays a guessing game with numbers. The computer should pick a random number between 1 and 100 inclusive. So inclusive just means they could pick 1, they could pick 100, so including the endpoints. That's what I'm going to give you notes on in a second because you don't know how to do that right now. The program should then keep asking the user to guess the number. On each guess, report to the user that they have guessed too high, too low, or guessed correctly. Keep accepting guesses until the user guesses correctly or quits. When the user enters zeros, the program should quit. So think about right out already, if I pick a random number and you start guessing and I'm going to tell you higher or lower, you won't necessarily know how many times it's going to take for you to guess correctly. So think about what type of loop would be the best type to use and think about how you would know when you should stop doing that loop. Count the number of guesses and report that value when the user guesses correctly. So you're going to be using an accumulator for num guesses to count up how many guesses they've made. At the end of each game, ask whether the user wants to play again. So you're going to want that again method that we've done before, enter 1 for yes, 2 for no, that kind of thing. For your output, run your program 3 times with 1 game where you guess 0 to quit. Okay, so let me show you how it works. Here's my working program. Heading still prints out at first. Computer's chosen a random number between, excuse me, 1 and 100, so that happens behind the scenes. What do you want to pick? Let's say I pick 50. It says it's too high, so I gotta pick something lower. Let's go 25. Too low. What should I guess next? Let's go 37. Still too low, so it's somewhere between 37 and 50. Let's say 44. Too high. Okay, somewhere between 37 and 45. Let's go 41. Also too high. 38. We got it. So when you get it, it says, congratulations, you got it. The number was 38. It took you 6 guesses to find the number, so double count to make sure it's that accumulator is working right. 1, 2, 3, 4, 5, 6. Yep, 6 guesses. Would you like to play again? Sure. Let's start with, let's go crazy. Let's try 35 this time. Too low. That didn't really help us. Let's go 75. Too high. Maybe it is 50 right in the middle. Nope, that's too high also. Okay, so we know we're between 35 and 50 already. How about 44 again? We got it. Wow, that was fast. Congratulations, you got it. The number was 44. It only took us 4 guesses to find that number. 1, 2, 3, 4. Would you like to play again? Sure, let's play again. 73. Oh no, I can't figure it out. I want to quit. If I type 0, it says quitter, the number was 4. That would have taken me a while to find probably. Would you like to play again? I think I'm over it now, so we'll say no. Program finished. Okay, so that's exactly what your output needs to be. You need 2 games where you guess all the way to completion, 1 game where you press 0 to quit. Obviously, everyone's output's going to be a little bit different, but I'm going to be checking to make sure your number of guesses is working correctly and that you press 0 to quit in one of your outputs. Okay? So overall, this isn't too tricky of a program. Again, we're going to do the random number notes now. Make sure that you know what type of loop you're going to be doing. You got to keep asking guess a number, guess a number, guess a number, and saying too high or too low until they guess correctly or press 0 to quit. And we're going to ask whether they want to run again. But either on the back or somewhere where you're going to do your hierarchy chart or another sheet of paper, because you're going to use these later this year also, let's do some quick random number notes. We've got to figure out how to make a random number from 1 to 100. So we can title this Random Number Notes. Okay, So the big idea with random numbers is that we're going to be using math.random. So it's kind of like math.round or math.pow or math.square root. It's a method that's already written in the math class, which is already loaded for us. We don't have to import anything. And what math.random does is it returns a double between 0 and 1. So it includes 0, but not including 1. So it's a double, so it's going to give you some crazy big long decimal, always between 0 and 1. So let me run that in Eclipse a couple times and show you what's going on here. Okay, so if I just do double x equals math.random, and let's do system.out.print, we'll do println x, just to see what it gives you. So when I hit play, there you go, big double, big decimal, it's somewhere between 0 and 1. And if I hit play again, it's going to give me a different number between 0 and 1. And whenever I hit play, it's going to give me a different number. It technically could give me the number 0.0000 forever, but it's never going to give me anything with a 1 here. So if I want a number that's bigger than 1, what would I have to do? Well, we can multiply this number by something. If we multiply it by something, it's going to make it bigger. So let's say I wanted to multiply it by 5. So let's call that y. Double y equals math.random times 5. Oops, I need to print that out. So we'll do system.out.print. I'll print out y this time. There we go. So there's my original number. Now I multiply it by 5. Now I got a number between 0 and 5 instead of 0 and 1. And you can see there's a 1 point, there's a 2 point, there's another 1 point, there's a 0 point, so I can still get zeros, there's a 2 point. And if I play this enough, you'll see lots of different numbers. But they're always numbers between 0 and 5. You're never actually going to get 5. We should be able to get some 4s in there. I don't know why they're not coming up. But anything between 0 and 5, including 0, there was a 4, there's another 4, not including 5. Okay, now let's say I wanted to make an integer. How could I make this into an integer? Well, if these numbers are between 0 and 5, really 0, 1, 2, 3, or 4, it's that number out here that I really care about. These decimal numbers don't really matter to me. So what can I do that would lop off all of these and just leave me with that number out front? Cast it as an int. So let's do that. Int z equals int math.random times 5. So notice I have to do all of that work first. I have to multiply by 5 first, and then int it. If I didn't do that, I'd always get 0. Because math.random, if I int that, it's always going to be 0 point something. And then if I multiply 0 by 5, I'm still going to get 0. But if I put this in parentheses, this is going to happen first, and then I'm going to int that. Let's print out z also so I can see that. Oh, because I'm getting different numbers. Okay. Let's say I used, let's make this x times 5, so it's the same number every time. And make this just inting y. Let's try that. You can see the progression. So there's my original number. Multiply it by 5 to get that number. Cast as an int. My random number is 1. There's my original number. Multiply it by 5 to get that number. Cast as an int. I get 4. And you can see I'm going to get numbers 2, 4, 2, 2, 0, Should be able to get 1. There's a 1. Should be able to get a 3 eventually. Lots of 1s and 0s right now. There's a 3. So I'm getting all integers from 0, 1, 2, 3, or 4. Okay, so let's kind of talk about what just happened here. In our example, I cast as an int math.random times 5. And what that did was it gives a random int between 0 and 4. And the way I knew that is because originally math.random gives me a number between 0, including 0, and 1, but not including 1. If I multiply by 5, you can see just mathematically that's going to give me a number from 0, because 0 times 5 is 0, less than or equal to x, strictly less than 5. The key is here, the way that program's written, or the method's written, it's not equal to 5. So I can't get 5 if I want that. Okay, so now let's talk about our program. We want a number between 1 and 100. So somewhere in your program, we're going to make a random number. I'm just going to call it int num. We want num to be a random integer from 1 to 100. So if I do num equals, just like I did a second ago, we got to cast it as an int. And then we got to say math.random. If I multiply that by 100, what's that going to do? Well, that's going to take our original math.random that goes from 0 to 1 and multiply that by 100. Then it's going to give me a random int 0 less than or equal to x less than 100. So what is that? That's going to give me a number from 0 to 99. But I don't want 0 to 99, I want 1 to 100. So what would I need to do to this statement to get that to be 1 to 100? Well, if whatever number they give me, I bump up by 1, now the lowest I can get would be 1, the highest I can get would be 100. So if I put a plus 1 on the end here, end it with a semicolon, then I'm going to take that range, add 1 to both pieces. Now I'll have a random integer from 1 less than or equal to x less than 101. That's exactly what I want. It's going to give me the 1 because that part's included. It's not going to give me 101 ever, but I could get 100, which is perfect. So this is the important code right here. And in your program, you're probably going to want a method called like generate random number. There's your method. So whenever you want to make a new random number in your code, do that. And this will probably be a variable up at the top of your program, so it'll really, if you have a method called generate random, it's going to be just that line right here. Okay, so now you know how to make a random number. What I need to see in your hierarchy chart is I need to see a run method, and I need to see how you're going to do your important methods. So generate random, just copy this right over. Maybe you want a method to compare higher or lower. You're going to want an again method, the usual. Okay, so as always, feel free to ask me if you've got any questions or if you're stuck on your hierarchy chart, but get to work. Good luck.